This is Lake Tahoe. Deep, blue, clear, and cold. More than a mile high in the Sierra Nevadas. Surrounded by forests of pine. Guarded by jagged, snow-struck mountains. A place that beckons people closer to the lakefront, to the quietly spectacular pleasures nature provides there. But there are other reasons people come here too. Casinos, gambling, entertainment that goes on and on. And for many weekenders, campers, winter skiers, and tourists, the South Lake Shore is sought out for this kind of excitement. Whatever the reason, though, the fact is that California's portion of the South Shore is visited by more people each year. And they're staying, some for just a season, many all year long. This means development, construction of summer homes, winter homes, condominiums, beach houses, and it means some sizable pollution problems. Back in 1961, when it became apparent that growth would continue in the lake region, the South Tahoe Public Utility District initiated a long-range program for development of a new sewage treatment process. A process more advanced than conventional secondary treatment, a process that could effectively handle wastewater disposal problems here. What the district and its consulting engineers came up with was the world's pioneer advanced wastewater reclamation plant, capable of producing water better than many drinking water supplies.
In my many years as a contractor at Lake Tahoe, I have experienced firsthand the pressures of the population growth. I don't personally feel that these pressures have been detrimental to the water quality of Lake Tahoe because our district runs the most advanced wastewater treatment plant in the world. We feel that we have done our share to keep Lake Tahoe clean in spite of the growth.
This is what it's all about. I've been visiting the lake, have lived here for some 30 years, and I believe that that beautiful blue out there is just as pretty and just as clear as it has been since I first arrived.
I feel that a great deal of responsibility rests with the directors of the South Tahoe Public Utility District in preserving the lake, its quality waters for the young people, the people who are now in school, the people who will want to enjoy these facilities, this lake, the environment in the years to come.
This is the South Tahoe Wastewater Reclamation Plant today. Model for wastewater reclamation and reuse for this country and the world. Planning, design, and engineering for the South Tahoe plant was done by CH2M HILL, a leading national environmental systems firm. Russell Culp, a member of the design team on the project, explains the treatment process.
Wastewater reclamation at this plant goes far beyond conventional secondary treatment. It's basically a wastewater treatment plant followed by a water purification plant followed by carbon adsorption. All of the organic and chemical wastes, solid wastes, are incinerated to sterile ash.
The primary and secondary treatment stages of this facility are common conventional ones used by many cities. The tertiary, or AWT stage, however, is one of the most advanced in existence and embodies several engineering achievements. Let's join this group for a tour of the plant. The tertiary process starts with chemical treatment for removal of phosphorus and nitrogen, nutrients that cause algae growth. Lime is introduced, combining with phosphorus in the wastewater to form a settleable calcium phosphate solid. and raising alkalinity to allow nitrogen removal later in the spray ponds and stripping tower. The research done at Tahoe has led to the development of even more advanced nitrogen removal systems. Systems which can remove and recover ammonia nitrogen for use as fertilizer. This is a chemical clarifier. Here, most of the lime and calcium phosphate settles out of the wastewater and is removed by sweeper arms. The highly alkaline wastewater, now minus phosphorus, is pumped from the clarifier to special high pH ponds, where it is sprayed into the air through high-powered nozzles. Besides looking like a giant fountain, the spraying breaks the water up into droplets, allowing nitrogen-laden ammonia gas to escape. Ammonia removal continues in a spray tower. Water is sprayed into a mist inside the tower, freeing more ammonia gas. This gas is blown away from the water by powerful fans. Following this, carbon dioxide is added to lower water alkalinity to normal levels again, and breakpoint chlorination for additional nitrogen removal begins. Physical filtering of remaining solids from the water is the next step. The filters at South Tahoe are specially designed steel tanks filled with sand-like materials or media of different sizes and weights. As water is forced through the filters, impurities are trapped by the media grains. From the filters, the water is pumped to a series of carbon columns. Each of these columns contains 24 tons of activated carbon, which removes dissolved organic materials by adsorption as the water flows from the bottom to the top of the columns. A final chlorine disinfection sequence ends South Tahoe's tertiary treatment process. The resulting effluent is a high-quality water, ready for discharge and beneficial use. 2 summers of testing indicate that it's not only free of measurable virus, but also has a lower bacteria count than many city water supplies. Nearly as remarkable as the water reclamation process is the materials recycling done at South Tahoe. Nothing is wasted. Lime sludge from the chemical clarifiers is dewatered, recalcined in a gas furnace, and recovered for reuse. Carbon from the carbon columns is thermally regenerated and returned to the process. Even the stack gases from the furnaces are drawn off and used. The only waste product from the plant is an insoluble sterile ash, residue from incineration of biological sludge, which is taken to a landfill. Even this ash may be useful as ways are found to turn it into building blocks or paving material. This, then, is the South Tahoe AWT process, first of its kind in the world, operating with high efficiency, making the principle of reuse and recycle actually work. And the plant people are not satisfied yet. Research is conducted constantly to find new ways to improve treatment levels and put process byproducts to work. This device, for instance, is testing the feasibility of a new ammonia removal and recovery process. Because the goal remains to produce from common sewage a water that is clean and pure enough to drink. The reclaimed water from the South Tahoe AWT plant could be returned to the lake, but it isn't. California law requires all wastewater to be exported from the lake basin. So it's pumped here over Luther Pass to Alpine County, to Indian Creek Reservoir.
Indian Creek Reservoir is one of our better fisheries in Alpine County. It produces many good limits of fish, up to 7.5 pounds. It's tremendous fishing.
Use of reclaimed sewage to make a lake was a novel concept when South Tahoe tried it.
Well, their first proposal was they were going to subterranean dump this right here in Hope Valley. And, of course, we didn't understand sewage at that time like we do now, but there was no way that we were going to allow this.
But the concept, to provide a recreational resource a lake safe for boating, swimming, fishing, and camping, worked.
It's a good fishery. And I mean that. I got one in my freezer back there. He's in water. I had to bring him out. About like that.
There's another use for South Tahoe's reclaimed wastewater, too. Irrigating this alpine county rangeland, making usable pasture out of land that used to be a desert.
The field we are now looking at is being irrigated for the third year with water from the Indian Creek Reservoir. Before we had the water from Indian Creek, this field was a rather barren field. This time of the year it would be all dry. We were able to run 15 head of cattle for the summer, usually, if it was a good year. Now we are able to run about 65 head in the same area.
This story of the success of South Tahoe's AWT project is not a recommendation that the process be used everywhere. In many cases today, analysis and careful balancing of receiving water requirements, energy use, land availability, and environmental factors will dictate use of other treatment alternatives, such as this secondary facility in Oregon. At Lake Tahoe, though, water reclamation and reuse through advanced waste treatment was the best answer. And the Tahoe AWT concept has opened the eyes of governments and environmental authorities in a lot of other places, too. CH2M HILL has designed facilities on the Potomac River near Washington, D.C., where water supplies are critically short. And again on the northern shore of Lake Tahoe in California, where the new Tahoe Truckee AWT plant will produce even better quality water than its predecessor to the south. Testing for AWT is being conducted at Lake Biwa in Japan, where severe water pollution has resulted in tight government wastewater standards. Other engineering firms have also adopted the Tahoe process and used it in their own designs. On the lower Potomac River, at Hatfield Township in Pennsylvania, in Orange County, California, where treated water from AWT and desalting plants is pumped directly into the ground to replenish the groundwater aquifer and stop saltwater intrusion. Advanced waste treatment, AWT, a process pioneered and proven at Lake Tahoe, now being put to use around the world. A process that can produce from common sewage a potable effluent, a process that can put back into receiving streams better water than was removed in the first place.
Through the efforts of the district, wastewater disposal problems for the lake certainly have been solved.
A lot of people said we couldn't keep this lake clean. There it is.
The STPUD has cleaned up this lake. It's as clear as it was 100 years ago. And we want to keep it this way forever.
This is Lake Tahoe. Deep, blue, clear, and cold.